Hello, welcome to my new channel, Coding with Juicy. This channel is going to be all about talking about basic computer science concepts and teaching you easy things to help you get started with programming. And today, we're going to be talking specifically about programming data types. What are data types? Data types within programming are data labels used to tell the computer what a variable is and how that variable can be used. Understanding the differences in data types can help you as a programmer understand where to use them and to ensure that your desired formatting is correct. Using proper data types also helps your computer's memory efficiency, as each data type has a different memory allocation amount depending on the language. What data types are widely used? First of all, we got integers, pretty common. We've got floats and doubles. Those are basically your decimals. We've got chars or characters. We've got strings and booleans. However, in this video, we're going to be talking specifically just about numbers, the number types. So your integers, your double, your float, and your decimals. So let's get on with that. Integers are whole numbers, positive or negative, with no decimals. Integers are used for simple counters, unique intermittent IDs, loops, etc. And here we have a nice little for loop example in C sharp. The syntax for this is for parenthesis int I equals 0. So your integers here, you're initializing I to equal 0. I is less than 10. This is how far the loop is going to go. And then I plus plus increments I from 0 to 1 to 2 to 3. And then within the for loop, we just have a console.writeLine I. If you can't guess, the output of this for loop would just simply do a 0, 1, 2, 3, 4, all the way to 9. It would not do 10 because this does not include 10. Floats are decimal numbers with about 7 accurate decimal digits. It kind of depends on which language you're using, but about 7 is pretty accurate. Floats are used when you want to keep memory usage down and you aren't needing extremely precise decimal numbers. Float calculations are faster than a double, and we're going to move on to doubles right now as well. Decimal numbers are about 15, or sorry, doubles are decimal numbers with about 15 accurate decimal digits. Doubles are more commonly used with calculations because of their increased precision. So we're going to go move over to our code, and here I have a Python file. This is simply showing that we do have dynamic data typing in some languages, specifically Python. So you can see that X right now we have equal to 5, Y is equal to 4.5, and Z is equal to Jordan. However, if we run this file, right now I've got a print type X, type Y, type Z, and then a print X plus Y. So if we run this, we can see that our X being 5, it knows that that is an integer. That's a class int. We've also got Y equal to 4.5. That would be a float. And then we've got Z is equal to Jordan. That would be a string. And str is just a shortened edition of a string. And then as you can see, we can add together integers and floats. So we have an X plus Y, and down here in our output, we've got a 9.5. And then just to show that you can't really mess with the IDE or with the language, I put in a try and accept, which maybe we'll talk about one day, but for now, let's leave this here. Basically, I'm telling this to try to make result equal to X plus Z, which X we know is 5, Z is my name, Jordan. Do you think you can add together a number and a string? In Python, you cannot. So, once it realizes that this is a type error, it doesn't match, it just says error cannot add int to string, and that also gets put in the output down here. And then something really interesting that I wanted to show as well, floats, because they are only precise up to a certain amount of decimal points, I have a num1 is equal to 0.1 and num2 is equal to 0.2. And you'd expect this to just simply be num1 plus 1, 2 is 0.3, right? However, in code, if you don't round it or do other things with it, you get some funny things with floats. And you'll see down here that we've got a 0.3 and tons of zeros and then a 4. And a lot of this is just junk that the language adds on to the end of this zero point 0.3 because it is they are two floats. And it just thinks, hey, well, what if we just throw on some garbage values to fill in the rest of the decimal places? And so if you want to really work this down to just the point 0.3, you'd be able to round that to the point 0.3. Now, we're going to move into Java. So we're changing languages, going from Python to Java. And I'm going to write some little code here. Um, and like I said, Python has what we call dynamic data typing. So Java does not do that. It does static. So what Java would like us to do when we create variables, we want to make sure we specify this one is going to be an integer, x equal 5. Don't forget your semicolons. We're going to do a double y. LA wants us to do pi, but we're going to just say like 5.5. And what we're going to want to do to show this, we're going to say system.out.println x. That's going to be x, and then we're going to do a y. It's filling it in for us, which is really nice. And then this one, we're going to actually want to do an x plus y equal to x plus y. And this, as you can see, we're just concatenating together a string and then having it do some math. And if you really want to be careful about the order of operations, you can make sure you do your extra parentheses there. And so now if we run this file, we'll see here, we've got our printed x, which is 5. We've got our printed y, which is 5.5. And then x plus y is equal to 10.5. So once again, you can add together integers and doubles. And here we are just using doubles instead of a float. However, we're going to talk about some floats here as well. So if we do float num1, we're going to just do tons of random numbers, okay? Just tons of them. And then make sure to put an F at the end for float. Otherwise, it'll be mad, as you can see. So make sure you throw an F at the end there. And then we're going to do a double. Num2, it's going to be the exact same number, but without the F. And then we're going to output num1, which maybe we'll just put some labels on here just to make sure we get the whole thing here. Do a double. And the IDE is helping a lot here. It is filling in a lot of this for me. So as you can see, we're going to run this again. Our float is cutting off at that 7 digits that we said in the slideshow. So it's doing 2563424. As you can see with 2563426. So this 4, it's kind of just throwing a garbage value at the end here. It's not taking the 6. So that's why you'd want to, if you have any longer than, I'd say 5, 6 digits on your decimal places, I would always go with the double because this can store much more. And then to showcase some different interesting things with what we call casting, you are actually able to turn integers into doubles and different things like that. So let's take a double of num3. You know what, might as well use just the same number up there that it had us fill in there. You can actually take this double, and right now it's going to say, hey, there's the double. We're going to do another one. Let's do print line, and then we're going to say double as int. Oh, missed a couple typing, or a couple letters there. And we're going to basically put in parentheses int, and then num3. So what that's going to do, oops, extra L there. What this is going to do, it's going to take our double, 5.25, blah, 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 blah. First, it's going to display this as the normal number. And then the int, this is what we call a cast. It's going to take num3 and say, okay, if this was an int, what would it be? And if you couldn't guess already, the integer version of that double is just going to be 5. It's going to round, it'll take, say we change it to 5.8. It's always going to round down. It's just going to drop all of this off. Doesn't matter if it's a 0.8, if it's a 0.1, it's not going to round up at all. It's always just going to take the integer. So kind of interesting things there. And then There also are a couple other different integer types in case you're ever curious. So there are bytes, and we'll just say my byte 127. So bytes can actually go from negative 127 to 127. And you could use this potentially if you're trying to save memory, different things like that. And then there's another one that also would be a short. You do my short. These actually go from negative 30 to 768. Oh, that's fine actually. And then those also go to positive 32,768. So those are some other interesting data types if you wanted to save memory because integers go to whatever the number is. I can't remember off the top of my head right now. Um, but yeah, these are your basic data typing things. You've got your integers, your doubles, your floats, and as you can see, floats only store accurately about 6, 7 digits. Doubles can do up to 15. And of course, if you want to cast different things, you could go either way. You could go from integer to double or double to integer with a cast just like this. And yeah, we'll move on to strings and characters and booleans next video. And appreciate you guys watching, and I'll see you next time.